So the pop quiz, which was related to DC electricity, the pop quiz 3, we have a cell of EMF is connected in series with a variable resistor as shown. The internal resistance is R here. When R is the capital, like when R is 12 ohm, the reading on ammeter is 170 milli, and the circuit is switched on for 30 seconds. In this time, 50 joules of energy is transferred by the cell. We have to calculate the R. We have to calculate the internal resistance. So first, what we can do, we can work out because the formula is EMF is equals to V, the output voltage divided by voltage drop internally, capital I into small r. What is the maximum EMF? It's the how much energy is EMF is like the maximum energy which can be transferred. So we can work out the EMF is equals to work done per unit charge or energy divided by charge. So energy is 50. And what about the charge? We don't have the charge, but we can work out as we have the current. We have the 170 milliampere current is there. Sorry, 107 milliampere current is there. And we have 300-second time is there. So I is equals to Q divided, the current is equals to charge divided by time. So charge is current multiplied by time. So this will be current multiplied by time. So it will be 107 milli multiplied by time is 300. This will give us the maximum voltage, the EMF of the cell. That is equals to 1.56. And so the total EMF, this formula, we can also modify if the output voltage plus input voltage. So V is equals to IR. So EMF is equals to IR plus I into R. So EMF here, we worked out that is 1.56. I is the current that is given 107 milliampere, so 10 power minus 3. R is the external resistance, which is 12 plus I is 107 into 10 power minus 3 multiplied by external resistance R. So when we simplify, like multiply this will, after multiplication, this will be subtracted to other side, and this 107 exponent minus 3 will be divided. So when we simplify, we'll get the value for R, which will be about 2.56, and unit will be ohm. So first we work out the EMF, and then from its EMF, we work out the internal resistance. Increasing R would make the terminal potential value closer to E. Without calculation, explain why without further calculation. Look, when we increase the value of R, what will happen to the current? The current, if R is increasing, so increasing R, as a result, what will happen? The less potential will be there across the internal resistance because the value of the current will decrease. So if R is increasing, because we don't have to do any calculation, EMF is equals to IR plus I and small r. So as a result, when the value of R is increasing, so this voltage will increase because the total sum should be constant. So voltage across the internal resistance will decrease. This is constant. The total EMF is like 1.56, which is constant. So when we increase the value of R, the external voltage, this voltage increases. As a result, the internal voltage decrease. And eventually what will happen? The value of IR will be very small or negligible. So in that case, the EMF is equals to IR. So increasing the R, what it will give? It will give a like greater voltage will be drop in the externally and less voltage will drop internally, or the value of IR will become less. Voltmeter is added to a circuit as shown. Explain how the circuit can be used to determine the value of R using a graphical method. So this is a even in a the paper unit 2 you have some experiments. So this is related to experimental part, like how we can work out the internal resistance. So first we'll measure the voltage and a current. Like using a voltmeter, we'll measure the voltage and current. Voltage by voltmeter and current by ammeter. Then what we will do, we will gradually reduce the resistance and record new voltage and current. So we reduce the resistance and we'll record new voltage and current, and then we'll plot a graph between the voltage on y-axis and the current on x-axis. And then we'll find the gradient. And the gradient will be equals to negative of internal resistance. So initially, when the value is very high, like when the resistance of a variable resistor is very high, so we have here voltage and we have current. So the current will be zero. So all the voltage will be there across the, like no voltage loss. And as we reduce the resistance gradually, the current start to increase, so less potential across the terminal. So we'll have a linear graph between a voltage and a current. And when we work out the gradient of this graph, the gradient of this graph will be negative of internal resistance. So how the marks are distributed, we'll take the reading for a voltage and a current, and we'll reduce the resistance and record the new value for voltage and current. We'll plot the graph and the gradient will give us negative of the internal resistance. So this was a pop quiz 3 related to DC electricity.